Imagine a world without wires, a world where the clutter of cables and the constant search for power outlets are things of the past. Picture a seamless, efficient, and aesthetically pleasing environment where technology integrates effortlessly into our daily lives. No more tangled cords or hunting for power outlets. The frustration of dealing with messy cables behind your TV or on your desk would be a distant memory. This vision of a wire-free world isn't just a fantasy, it's becoming our reality. This was the vision of Nikola Tesla, a brilliant inventor who dreamt of transmitting energy wirelessly. Tesla's experiments and inventions laid the groundwork for the technology we are beginning to take for granted today. His pioneering work in the late 19th and early 20th centuries was revolutionary, setting the stage for a future where energy could be transmitted without physical connectors. Today, his dream is a reality, shaping how we power our devices. From the convenience of placing your phone on a wireless charging pad to the innovation of charging electric vehicles without plugging in, Tesla's vision is alive and well. The technology has evolved, becoming more efficient and accessible, transforming our interaction with energy. Wireless charging, once a futuristic concept, is now an integral part of our lives. In offices, homes, and public spaces, wireless charging stations are becoming ubiquitous. This technology is not just a convenience, it represents a significant shift in how we think about and use energy. From smartphones to electric vehicles, this technology is changing the way we interact with energy. The ability to charge devices without physical connectors is revolutionizing industries and paving the way for new innovations. Imagine a future where all our devices, from kitchen appliances to medical equipment, are powered wirelessly. Remember the frustration of fumbling with cables in the dark? The annoyance of trying to plug in your phone charger when you're half asleep? Those days are fading as wireless charging pads become commonplace. The simplicity and ease of use are making a significant impact on our daily routines. Those days are fading as wireless charging pads become commonplace. In bedrooms, offices, and even coffee shops, wireless charging is becoming the norm. This shift is not just about convenience, it's about creating a more efficient and user-friendly environment. It's a simple concept with a profound impact, freeing us from the limitations of physical connectors. The freedom to place your device on a pad and have it charge without any hassle is transforming our relationship with technology. Clean, wire-free setups are becoming the standard, enhancing both functionality and aesthetics. But how does this seemingly magical technology actually work? What makes it possible to transfer energy through the air without any physical connection? The answer lies in the principles of physics that have been known for centuries. The answer lies in a fundamental principle of physics known as electromagnetic induction, a phenomenon discovered by Michael Faraday in the 19th century. Faraday's discovery of electromagnetic fields and their ability to induce electric currents was groundbreaking, laying the foundation for modern wireless energy transfer. We'll delve into the fascinating world of electromagnetic fields and discover how they enable the transfer of energy through thin air. By understanding the science behind this technology, we can appreciate the incredible advancements that have turned Tesla's dream into today's reality. Electromagnetic induction may sound complicated, but the concept is surprisingly straightforward. At its heart lies the relationship between electricity and magnetism. When an electric current flows through a wire, it generates an invisible force field around it called a magnetic field. This field can then induce or create an electric current in another wire placed nearby, even without any physical contact. This elegant interplay between electricity and magnetism is what makes wireless charging possible. It's like an invisible bridge for energy, allowing power to flow from a source to a device without the need for wires. Think of it as an energy handshake across a small distance. This principle is not just a scientific curiosity, it's the foundation of countless technologies we rely on every day. Electric generators use it to produce electricity, while transformers use it to adjust the voltage of electrical currents. And now, electromagnetic induction is at the heart of the wireless charging revolution. To understand how wireless charging works, imagine a pair of dancers moving in perfect harmony. One dancer, the transmitter, initiates the movement, while the other, the receiver, responds in sync. This elegant exchange mirrors the interaction between the charging pad and your device. The charging pad, acting as the transmitter, contains a coil of wire called the transmitter coil. When you connect the charging pad to a power source, An electric current flows through this coil, generating a magnetic field around it. This field is the invisible link that bridges the gap between the charger and your device. Your device, the receiver in this wireless dance, also contains a coil of wire called the receiver coil. As you bring your device close to the charging pad, the magnetic field generated by the transmitter coil interacts with the receiver coil. This interaction induces an electric current in the receiver coil, effectively transferring energy from the charging pad to your device. The transfer of energy between the transmitter and receiver coils is known as inductive coupling. This process involves creating a magnetic field through the transmitter coil, which then induces a current in the receiver coil. It's a fascinating interplay of physics and engineering that allows for the seamless transfer of power without the need for physical connectors. This method of wireless power transfer is highly effective over short distances, typically a few millimeters to a few centimeters. The close proximity ensures that the magnetic field generated by the transmitter coil is strong enough to induce a current in the receiver coil, making the energy transfer efficient and reliable. Think of it as a close-range energy beam, requiring the device to be placed in close proximity to the charging pad. This is why you often see devices like smartphones and smartwatches needing to be carefully aligned on their charging pads to ensure proper charging. This close quarters requirement is why you need to align your smartphone or smartwatch carefully on the charging pad. If the alignment is off, the magnetic field may not be strong enough to induce the necessary current, leading to inefficient charging or no charging at all. The sweet spot for efficient charging is where the magnetic field is strongest and the energy transfer is most efficient. This is usually at the center of the charging pad, where the coils are perfectly aligned to maximize the magnetic field strength. Move your device too far away, and the connection weakens, much like a Wi-Fi signal dropping out of range. The further the receiver coil is from the transmitter coil, the weaker the magnetic field becomes, reducing the efficiency of the energy transfer. Inductive coupling is the most common method used in consumer electronics today. From smartphones to smartwatches and even some household appliances, this technology has become an integral part of our daily lives. It's the technology that powers your wireless smartphone charger, your smartwatch charging cradle, and even some electric toothbrushes. The convenience of simply placing a device on a pad to charge has revolutionized the way we think about powering our gadgets, and even some electric toothbrushes. These devices benefit from the simplicity and reliability of inductive coupling, making them easy to use and maintain. While its range is limited, its simplicity and affordability have made it the go-to choice for a wide range of applications. From consumer electronics to medical devices, inductive coupling continues to be a reliable and efficient method for wireless power transfer, ensuring that our devices stay charged and ready to use. Section 5. Resonant inductive coupling, reaching further. While inductive coupling excels at short-range power transfer, researchers are constantly pushing the boundaries of wireless charging technology. The quest to eliminate cables and make power transfer as seamless as possible drives innovation in this field. Scientists and engineers are exploring new methods and refining existing ones to extend the range and efficiency of wireless power systems. One promising advancement is resonant inductive coupling, a method that extends the reach of wireless power delivery. This technique leverages the principles of resonance to achieve more efficient energy transfer over greater distances. By fine-tuning the system, researchers have been able to push the limits of how far and how efficiently power can be transmitted wirelessly. Imagine a singer hitting a high note that causes a crystal glass to vibrate. This is a classic example of resonance where the sound waves match the natural frequency of the glass, causing it to vibrate. This same principle can be applied to wireless power transfer. This phenomenon, known as resonance, occurs when an object is exposed to a frequency that matches its natural frequency of vibration. When this happens, the object absorbs energy more efficiently, leading to increased amplitude of vibration. In the context of wireless power transfer, this means that energy can be transferred more effectively between two resonant objects. Resonant inductive coupling borrows this principle to enhance wireless power transfer. By tuning both the transmitter and receiver to the same resonant frequency, energy can be transferred more efficiently over a distance. This method reduces energy loss and increases the range at which power can be effectively transmitted. In this method, both the transmitter and receiver coils are tuned to resonate at the same frequency. This synchronization creates a stronger coupling between the coils, allowing for efficient energy transfer. The precise tuning is crucial for maximizing the efficiency and range of the power transfer. This shared resonance creates a stronger coupling between the coils, allowing for efficient energy transfer over greater distances, even up to a few meters in some cases. This is a significant improvement over traditional inductive coupling, which is limited to very short distances. Think of it as fine-tuning the energy beam to reach farther and with less energy loss. By carefully adjusting the frequency and alignment of the coils, researchers can optimize the system for maximum efficiency and range. This fine-tuning process is essential for achieving the best performance in wireless power transfer systems. This advancement opens up exciting possibilities for wireless charging, enabling applications where direct contact is impractical or inconvenient. From consumer electronics to industrial applications, the potential uses for resonant inductive coupling are vast and varied. Imagine charging your electric vehicle simply by parking it over a charging pad embedded in your garage floor. No more plugging in cables or worrying about connectors. This technology could revolutionize the way we think about charging our vehicles, making it more convenient and efficient. Or powering your laptop without the need for any cables. Just place it on a wireless charging pad and let the technology do the rest. The convenience and flexibility offered by resonant inductive coupling could transform our daily lives, making wireless power a standard feature in homes and workplaces around the world. Imagine a world where you never have to worry about plugging in your devices again. Wireless charging technology is making that a reality. From your smartphone to your earbuds, you can now power up simply by placing them on a charging pad. It's convenient, it's efficient, and it's becoming more and more accessible. As we move towards a more connected future, wireless charging is playing a crucial role. Public spaces like cafes and airports are integrating wireless charging stations, making it easier than ever to stay powered up on the go. It's not just about convenience, it's about creating a seamless experience in our daily lives. So, what's next for wireless charging? Well, we're looking at a future where charging pads are no longer needed. Imagine walking into a room where your devices start charging automatically. Researchers are working on technologies like resonant inductive coupling and radio frequency charging to make this a reality. The future is wireless and it's closer than you think. Wireless charging isn't just a trend, it's a transformative technology that's here to stay. As we continue to innovate and improve, the possibilities are endless. From reducing electronic waste to creating more sustainable energy solutions, wireless charging is set to power the future. So stay tuned because this is just the beginning.